Should have a sheet on Stellar. Well, this will go on to Stellar as the intro, okay? The administrative details are, there are 2 sign-in sheets going around. Make sure if you want to be in the course, you sign one of these 2 sheets. They're actually both up here. Anybody in the back not signed in yet? Okay, fine. Well, you've taken the course. So anyway. And my assistant, Jerry Hill, is just down the hall in 4138. It became an online class a number of years ago, but the last couple of semesters we've required an attendance of 6 students because the students were taking it a little too, well, let me be frank, we didn't have anybody to lecture to, okay? If you could just watch it at home. And so we decided, okay, you're going to have to come to class because we like questions and whatnot. So, but you're going to find that 4 days a week we're going to have lectures by 1 of 4 people. And if you can pick one of those days, you go for 6 weeks and you finish your lecture requirement. There are 2 modes, okay, of doing lectures. There are some lectures that go for 12 units, 12 classes, and there are some that are 6 lectures. Originally we had 12 for everything. I found the students like smaller bites, okay? You have to take 36 lectures because if it's a 12-unit course and you multiply by 3 hours a week, which is the official thing at MIT, that's 36 lectures, so you've got to take some combination of 12 and 6 that adds up to 36. Some of these you'll have to take online because you're only going to get 24 lectures live this semester, okay? And the others were done in previous years. You'll see that. Class schedules says I'll be doing Monday, Tuesdays, and Fridays will be Steve Lyon, so he will get his 12 lectures in because he gets to go twice a week, okay? Wednesday is Donald Baskin. We'll be talking about lightweight automobiles. And Thursday, Brian Homan will be talking about Leonardo da Vinci and mechanics. Dr. Belmar's here. He'll tell you in a little bit. I'll give him a little bit of time to talk about his. This class kind of blossomed up to like more than 40 students. And we used to let you do a paper. The Institute says I have to have something that you're required to do as an individual in order to give you a grade. If it was up to me, I'd just have you come to lecture, okay? But I have to do something, so we used to do presentations, and they were great. The students loved them, but I would have to listen to 40 or 50 presentations. And anyway, so Brian's going to help me this year. And we're going to give you an option, or you can either do a paper, which is a 10-page paper, or you can do a 10-minute presentation. And you don't have to write anything, okay? So the theme is flexibility in a stress-free environment. You know, the administration talks about we got too much stress on the students, and what do they do about it? Nothing, okay? So I decided that I'm post-tenure, well, I'm not post-tenure, I have tenure, and I'm post-retirement age. I can do anything I want, okay? And frankly, if you check around, I do, okay? That's what I tell my department heads. I'm going to do whatever I want. It doesn't matter what you want, okay? You can only do that at certain ages and other things. We'll talk about some of that. There's another part of this course, aside from being, this is the Department of Material Science and Engineering. And I went into it I chose it as a freshman. I've been at MIT for over 50 years, okay? So I chose Material Science and Engineering in the end of my freshman year because I couldn't decide whether I wanted to be a scientist or an engineer. And it was the only department in the whole institute, and still is, that has both, well actually maybe biological has both. But at that time it was the only department that had both science and engineering in the name. And so I've always wondered, or I've come to wonder over the years, what the difference is between a scientist and engineer. So I started collecting quotes from other people who tried to describe it. One person was Theodore von Karman. Anybody know who Theodore von Karman was? You ever hear of the Wright brothers? They taught people how to fly. Theodore von Karman explained why the Wright brothers were correct. He was a fluid mechanician. He started something called the Jet Propulsion Lab that kind of is affiliated with Caltech. He was probably the greatest engineer of the 20th century in the United States, okay? He did all kinds of things, okay? So he said, a scientist explains that which exists, an engineer creates that which never was. And I always like that because if I show it to scientists, they think that's a great quote about what a scientist is. If I show it to an engineer, they think it's a great quote about engineers. And Joel Moses, who used to be the provost around here, said, in the media lab, that's not median lab, in the media lab creates that which never will be, okay? And that's because they tell you, oh, we're going to build this computer that'll do blah, 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 blah. And they never have quite built these things. They always say, this is what could be, but they never know how to do it. So I actually still had some questions about what a scientist and engineer was. So what I did is I taught a 12-unit module in this course a few years ago on science and engineering. And that gave me the time and the discussion with the students to come up with some of my own quotes. I now have like a 7-page document, which is just quotes of what the difference is between a scientist and engineer, if you're really interested. But one of my favorites is, a scientist seeks to increase human knowledge. An engineer seeks to improve the human condition. Sorry, okay? And hopefully this is one, and I've tried it out a few times, that both scientists like and engineers like, just like von Karman's, okay? I'm going through this because this course is at the far end of the spectrum of science and engineering in the department. This is an engineering course. I used to say what I'm trying to do is teach you how to think like an engineer, okay? Now, you may not want that, okay? I mean, a lot of jokes made about engineers, fewer made about scientists. And in fact, among most respected professions, what's the number one most respected profession? Medical doctor. Why? Don't ask me. Okay. What's the number 2? A minister, a religious minister. What's number 3? A scientist. What's number 10? An engineer. Okay? So anyway, there is actually, I used to, when I taught this subject, part of it was, I discussed there's a hierarchy of snobbery, okay? And the scientists are at the top. They look down on everyone, okay? And the people that are at the bottom of that list, the scientist list, are actually the medical doctors. Okay, I already taught you that, engineers are somewhere in between, so I get to look down on the medical doctors. That's because the medical doctors are sort of empiricist, okay? Go home, take 2 aspirin, okay? Okay, there are a bunch of modules, and you can go to my website, which is eager, spelled with an A, and you'll get there easier, with an A on the end, .edu. Under classes, and this is not, I'm not going to be able to show you a complete list of modules. This hasn't been updated since 2018. There are more modules than this, but in any case, they're all available on YouTube. And Dr. Belmar's got a bunch of modules. Dr. Holman's got a module on non-destructive testing. Steve Lyons, didn't I put Steve in? I never even put you in, Steve. That was probably because it was this. I stole this from a semester when you weren't teaching. But anyway, so the requirements are watch 36 lectures. You get to pick your lectures. That's one of the things the students like about this course. They get to design the course for what they want. Okay, and it can be very different courses. Okay, you have to prepare a 1-page outline. I'm sorry, it says of each lecture module. It's not 1-page outline, but you need to prepare a 2 or 3 line. I don't know why I had that in there. 2 or 3 lines on what the key themes of that lecture were. Okay, This comes from when I was flunking quantum mechanics as an undergraduate, okay? I was a junior. There's no reason I needed to take a physics course in Introduction to Quantum Mechanics. It wasn't required for course 3. For some reason, I decided I needed to learn more quantum mechanics, so I took this course taught by Vera Kistiakowsky. Anybody ever heard of Vera Kistiakowsky? Her father won the Nobel Prize at Harvard in chemistry, okay? She was, I think, the first tenured woman faculty member in physics at MIT. And she was a wonderful teacher, but I didn't understand anything about what was going on in this course, okay? And so everybody else was getting 85 on their homework, so I was getting 15. I figured I was going to flunk the course. We had a couple of one-hour quizzes, and I kind of eked my way by at the bottom of the scale. And finally, the night before the 3-hour final, I thought, I'm going to flunk the course. I'm just going to take the book off the shelf and figure out what the high points are, okay? I walked in, I did the 3-hour final in an hour and 20 minutes, I walked out and got an A in the course. And all of a sudden, a light went off. I said, you mean all this other stuff they teach is just fluff? Okay? You only have to learn the high points. If you can write down the 2 or 3 key points that are in a lecturer in 1 hour cannot get across more than 1 or 2 points, maybe 3 points. They're packing too much in to do 3. If you can actually sit down and say, I used to call it guess my lecture. They don't give you an outline in the beginning, but if you can outline it at the end. So all I want is your 2 or 3, this lecture was about. And the interesting thing from these is the students can be watching the same lecture and what they write down is totally different. You wouldn't believe from those 2 or 3 lines that they watched the same lecture. Why? Because you understand based on your prior experience and your interest. And therefore, you write down different things. Your takeaways are different, okay? And so if we started thinking about that, most lecturers get up, and they expect you to learn what they know, okay? And they're going to hand it down from on high like, God gave the plates to Moses, right? Okay? And all you had to do is memorize it, right? And that's sort of the way they teach, right? Well, I don't believe in that. So I just want you to learn to walk out of any lecture, whether it's a class or not, whether it's just going anywhere and say, what's the takeaway? Can I give the elevator talk, okay, on what I just spent an hour of my life doing, okay? If you can, that's the thing you're going to actually remember out of that 1-hour event in your life. And from that point on, first term junior year, all the way through the rest of my undergraduate and graduate time, I never took a note in class. I said, why do it? I would just think, and I'd walk out of class and I'd say, what was the key point? And then I'd learned the night before the quiz, I'd go in, I'd see what the high points were, and I could get through here, okay? So to me, it was a great revelation to train yourself to figure out what are the key points. I think Steve will tell you as a lawyer that you got to learn to think like that when you're debating with a judge, right?
It helps thinking that way, just generally.
Right. So that's part of the learning of the course, is to write these down. So for a whole 6-unit module, there shouldn't be more than 1 page, okay? It's not as if I don't want to read all that. It's really for you to categorize what you think you learned. You can do a 10-page paper or a 10-minute presentation on a topic of your choice, and you're going to have to review 3 or 4 other student papers and presentations so you get feedback from someone other than just the faculty. Okay? And we'll go over this a little bit more, but well, that's just, we'll hand this out. Pardon me?
Taken the class before, it can't be the same paper.
Right. I've had some students, it says in the catalog, I got this through, because there's like 30 different modules you can take. I've had some students take this course 3 times, as long as they take different modules each time. Is anybody taking it the second time this time? Oh, 3. Okay. Oh, you don't count. You've taken it 5 times. Okay. but 2 of you have taken it before. So the thing is, there's lots of different things you can take. If you want to be pure structural materials, you can do pure structural materials. If you want to do more business management things, you can do Simone's lecture, you can do Steve's lecture. There's probably some of mine that I've strayed away from things. By the way, did anybody from Sloan show up? No one from Sloan? You're the only one. There were about 10 pre-registered. I bet Sloan came up with another course and you all had to take that. Anyway, before we go through those requirements, let me give Simone and the other people a chance to tell you what they're gonna have in their modules.
Okay, so I'm Simon Belmar. I was a PhD in course 3 and graduated in 2006. And I worked as a consulting engineer for a smaller company, a little bit like Exponent, but a smaller firm. And started my own consulting practice, probably about 30 years old. Was working with facility here quite a bit. And after a while, started teaching here, and it started a technology startup. That was 5 years ago. It's essentially a new way of doing hardness testing that provides accurate yield strength.
Oh, why don't you put this on? Oh, you can hear him? He's a loud mouth.
There's enough of YouTube, I mean,
Okay.
but. So the technology as it is today is we're commercial. There's actually new federal regulation. We work in a regulated environment, and that's a module Professor Eager talks about. It's a little bit like in aerospace. There's certain rules you have to follow in building the rules. So we test oil and gas transmission pipeline, and the reason it's regulated is there's life safety issues associated with those. There's 300,000 miles of those pipes just in the U.S. For gas and liquid. And what our technology allows is a lot of companies don't have historical records of the quality of the steel. Plus, the steel is not tested for fracture properties. And therefore, we go into excavation sites that they have to do for repairs and collect information while the pipe is still running. Because service interruption is something that's really not practical. Generally, it does involve turning down facilities that provide the compression or the pumping, and you don't make money if you can't run the pipeline. So I think that the 12-hour at this point is a walkthrough, essentially, this experience I've had starting at that company. And I'm proud of it. I'm proud of the sequence where you get a 6 hours first from 2 years ago. That was essentially mostly a summary of what was taught to us as entrepreneurs by the National Science Foundation. So it's providing some of what was applicable to our company back then. But then I supplemented it a year later with 3 hours more focused on the commercial aspect. And then I kind of tied it all in last fall. Talking about the team. Yeah, the National Science the National Science Foundation has one of the biggest R&D funding budget in the U.S. other than defense, and the regulation for the government requires them to spend a certain fraction of their budget in small businesses. It's called Small Business Innovative Research. So the bigger the agency, the more money they have in that bucket. So what the National Science Foundation does is they really invest in technologies that could be successful commercially. So it's really kind of an incubator for generating new businesses and growing the economies. They're not as partial to, well, I want this small company to help me make the next airplane, or I want this company to help me make this. They just want those companies to be successful. So they teach us how to really identify our market, focus on it, and deliver. So the 4 key phases is discovery of a customer, then you validate it. And you only validated a customer if they've written you a check. It's a very, very simple, clear criteria. If you don't have a purchase order or a check, you don't know really if they're going to pay for what you're doing. And that was something that I had to learn the hard way. I think there's a lot of this in this entrepreneurial path that you do have to learn the hard way, but at the same time, the more guidance. Here we have the venture mentoring service that I'm still a member of, so I'm going there this afternoon with my team. We have 16 people now, and we're growing probably to 25 before the end of the year because of the new regulations. So we're hiring at all levels between engineers, technicians, managers. And we are focusing now on leveraging our skills. So the marketing efforts are super big. A lot of people tell us that we're limited by our internal knowledge. So if the customers knew what we know, they would sign up right now. But we have to essentially have open houses, so we have people traveling to Boston from all over the country to visit with us, and it's one of the best marketing because they're starting to invest. If you're able to do something that is interesting enough to a customer that they'll co-invest with you their time or their money, then you know you're on the right path. So I invite you to follow the 12 hours. I will post on Stellar all the lecture notes, not for you to post them on the website. I try to keep them a little tight. And please send me questions. I still have my email address, but yeah, there's so many commitments for me right now that I can't do 3 to 6 hours. I would love to, but some other time. Thank you.
Any questions for Simone? Okay. Steve, do you want to come up? And as Steve's coming up, let me say that the Department of Material Science just had an offsite last week where they were looking at revising the graduate curriculum. And they did a survey of the graduate students, and the graduate students said they need to learn these types of things, how to be a manager and stuff, because when they graduate, they might have a PhD in materials, but they're liable to be thrown in as a manager, and they don't have any of those skill sets. So
We should be making money this year.
I better invest. Okay. Steve Lyons, do you want to tell them your background?
Good morning, everybody. I'm delighted to be here. I always start this lecture off by thanking Professor Eager for giving me the opportunity to stand up here on my hind legs in front of you wonderful people, and further Tom's approach to education here at MIT. Because as you can tell just by being here for 20 minutes already, Tom has a practical approach to education here for you material science engineers and everyone. If you want to know the principles behind material science and structural engineering, and you want to know how to be a structural engineer, and there's a difference between those two things, you've come to the right place. Simone, for instance, is Exhibit A, forgive the legal term, but there's a guy that, in my opinion, is going to be a millionaire, if he isn't already, Simone, in very short order. And what he has to tell you about how to turn his knowledge into something that you can market and become successful in is it's just absolutely invaluable. And in the same way, I hope to fill a niche in this course, in this curriculum. Tom, a long time ago, identified a gap in the curriculum at MIT. And that is that we teach you people to be the best the best scientists, the best researchers, the best writers, the best inventors in the world. And then we send you out there and don't tell you how to protect the results of your genius. And you end up getting taken advantage of. I'm here hopefully to fill that gap. Again, it's a practical approach to the knowledge that you're going to be getting in this course, how to protect what it is that you invent, how to turn what you know into something like what Simone has done, how to make millionaires out of everybody in this classroom based upon what you know. You know, the first lawyer I ever went to work for, and he eventually fired me, taught me something that I'd never forgotten, and that is you don't make any money working for somebody else. You make money working for yourself. And you are the best scientists, you are the best researchers, you are the best writers, you are the best engineers, and I'm going to show you how to hold on to what you develop. So I get to stand up in front of you twice a week. You can't possibly cover everything that we need to know in 12 weeks, but I will give you a working knowledge of not only what you need to know, but what you don't know, and will be able to find out on your own. Two things that I would ask. Tomorrow's the first day of class. I don't mean to contradict what you've heard already, but tomorrow would be, if you're going to come to any of my lectures, come tomorrow. Because I have a new way of teaching the course, and tomorrow is going to begin with a story. I won't take up the whole hour probably, but tomorrow's class is I'm going to tell you a story. And the story is going to be about you. And this story is going to inform and provide a framework for everything that I have to tell you during the term. And not only is it a story about you tomorrow, but it gives you context for everything that we're going to learn. And as a bonus, I'm going to feed you tomorrow. If you show up tomorrow, there'll be food from Flour Bakery. So you have 2 reasons to come tomorrow. All you have to do is sit there and listen to a story. And if that's not good enough for you, there'll be pastries from Flour Bakery in order to get you to sit through the story. And that story will provide a frame of reference for the entire term. Hopefully it's something that you will remember and take with you and use throughout, not only throughout the course here, but for the rest of your life. Because it's a story the story I'm going to tell you is something that has affected somebody for their entire life. So, and see you tomorrow maybe.
So let me give just a hint. That story he's going to tell is actually about a former student in this class. Okay? It's a real story. He'll probably disguise it to protect the guilty. Okay? Steve didn't really introduce himself the way I was thinking of it. Steve Lyons works for a firm called a law firm in Boston at One International Place, big high-rise, called Kleiman and Lyons. Okay, I know that over the last 4 or 5 years he's been teaching in this course. He has presented patent cases before the U.S. Supreme Court on at least 2 occasions. Okay, so he's not really a slouch. He actually has practiced in this field. He knows something about it. And that's, it's good to have Simone, who's working in the field, Don Baskin, who's not here to present things. Let me just, before I put Brian up, Don Baskin worked for like 10 or 15 years figuring out how to make lightweight automobiles for Mercedes and Chrysler. And it's not just fancy materials, it's not just fancy geometry, it's actually a mixture of both. And he's got a lot of real-life examples from real automotive companies. So it's fairly specialized in automotive. That's fine. It won't just be Chrysler and stuff. I mentioned the BMW i3. We had a student do that a few years ago in a presentation. It was a great presentation. The student had been involved in it when they were working and did a great presentation. Well, when I was talking to Don, he's got the BMW i3 in there. Anybody know why the i3 is sort of interesting? It's a 40 or 50,000,
It's all
graphite
materials.
It's graphite fiber.
Graphite, right?
It's a $40,000 vehicle made out of graphite fiber.
I was walking home the other day, and one almost ran me over. It was off a square.
Right.
Anyway.
And it's an all electric vehicle, and as you probably know, batteries are heavy. And I have 2 all electric vehicles. They're Chevy Bolts, and the battery costs $10,000 to General Motors that goes in that car, and they sell it to me for $30,000. Which, if you know that, what's the number 1 cost in an automotive firm for an automobile? Health insurance. Health insurance for the workers. Okay, the biggest single cost. The second is the frame, which would be the graphite fiber, and the third is seats. Anyway. Brian, you want to get up and tell us a little bit about yourself and what you're going to do this time other than... Now, Brian did his doctoral thesis with me a number of years ago on non-destructive testing. And come on up. No. I'm going to give you part of your introduction. So last semester he did 6 units on non-destructive testing, which is a module you can take. And he got very high marks. Unfortunately, not for me.
So the module that I'm going to do this semester, a little background on me. My undergrad was in ceramic and materials at Rutgers. I did my master's and my doctorate with Tom here. The master's thesis was a project for the Navy on using aluminum sandwich panels to reduce topside weight in carrier systems. And then the doctorate degree was on non-destructive testing of discs and blades, high-value parts on airplane engines. So the module I did last semester is more on NDE. It's on techniques for inspecting structural components. The module this semester is going to actually be more based on a trip I did to Rome a year or two ago, and it's on the mechanics and materials of Da Vinci. So it's taking his inventions as a war engineer from the 1450s to 1500s and talking about them at a very basic scientific level, and then trying to tie them into modern day techniques and where we're at now with the materials.
Okay, questions for either of them? He said maker of war machines. Does anyone know what the word engineer means and where it came from? It comes from the French, and it actually means maker of war machines. The first engineering school in the world was École Polytechnique in France. The first one in the United States, does anyone know what the first engineering school in the United States was? 1797, it's called West Point. And until 1845, the commandant of West Point had to come from the Army Corps of Engineers. The first engineering school or the second one after West Point was actually Norwich University in Vermont in 1821. But a better known one is in 1823, there's one called Rensselaer Polytechnic University. And they started a field called civil engineering in 1823 to distinguish it from military engineering. So now you know where the term civil engineering comes from. And anyway, so we could talk about that some other time. On some of the modules, I probably tell the long version of the story. And how, does anyone know what the original name of Harvard's engineering school is? They actually have one now, but they didn't have one for years. It's actually the Harvard Business School. It was built in 1921 to be Harvard's engineering school. I can explain it, okay, believe it or not. In any case, so you'll learn a number of things. You probably won't get a lot of equations. Of the modules that are on that I teach, some of the ones are on welding, because that's where I got my tenure. What was I going to say about the welding modules? In any case, I can't remember about the welding modules, but what I was going to say, but in the welding modules, I start out by saying I'm going to teach you one differential equation just to prove I'm an MIT professor. Okay? I'm going to ask you right now, and some of you have taken this class before, and so you already know the answer. Why does a professor spend a whole hour doing a derivation in class? Do you remember the answer?
Because they didn't prepare a lecture.
That's right, they didn't have time to prepare the lecture. And I'll tell you how I learned this in my first year on the faculty. When I came back from a trip and I hadn't prepared the lecture, I looked in the book and saw that there was a derivation. Oh, I can fill it up. And I thought, oh, that's why they waste that time. Okay? Anyway, so we can talk about some of the secrets of the faculty. And in fact, I was going to show you, if I can get this thing to come back. There is a syllabus that's on Stellar, and it says that Tom Eager was going to talk about Introduction to Structural Materials 3491. Professor Sadoway has been trying to convince the department to revamp the graduate core and have a graduate version of 3091. I took 3091 the first year it was ever offered over 50 years ago as a freshman, okay? And I've lectured, I guess I have lectured it once. And I've TA'd it, so I know what 3091 is. And I said, okay, when Jeff Grossman became department head a few weeks ago, I said, I can put together six lectures on structural materials. I can condense everything in structural materials down to 6 lectures in a 3091 version. And in fact, I've given you some handouts. Oh, actually, one of the handouts in there is the differences between scientists and engineers. This is my quotes of what other people say about scientists and engineers. But in here, aside from the syllabus, there's Steve's lecture notes, Steve Lyons' lecture notes, there are already on Stellar. There's Surviving at MIT, something that the students really liked, okay? Lessons I've learned about how to survive around here. But there should be something in here on, leadership, management, and education at MIT. I wrote this after about 37 years here at MIT about what makes MIT unique, okay? So I would encourage you to read this. I had a couple of faculty say that they were going to start reading the faculty newsletter again after I'd written that, okay? Because they thought it was worthwhile. In any case, there's all kinds of things that you can start reading, okay? But you're not going to be quizzed on it. One student said in their evaluation, they found they actually read more when they weren't required because they read what they wanted to learn. And your presentations and papers are supposed to be your choice. Now, we'd like them to have something to do with the modules, okay, instructional materials, but they're not always there. I mean, one of my favorites was when we were doing presentations, one year I had 2 students independently do presentations on pole vault poles because they were pole vaulters. And the interesting thing about a pole vault pole is it's made out of a sheet composite that's rolled up from the corner so that you get more material in the center than you do on the ends, so it's stiffer in the center. Okay? Pretty simple thing, but it teaches you the concepts of stiffness and geometry and material from something simple as designing a pole vault pole. And there were a lot of other interesting things in there. The presentations are great because the papers haven't been always so great because it's a pain in the neck to write a paper, right? We are going to ask you over the next couple of weeks to pick both a topic, tell us what the topic is. I don't want someone to pick a topic that's so general that in 10 pages or 10 minutes, you're going to tell me about the energy needs of the automotive industry. That's a little broad. I don't think you'll do justice to it. But the student who actually had worked on the BMW i3 graphite composite body and what they did, to get the cost down and the weight down, is a great thing. Probably more than you can do. But the pole vault poles were perfect in terms of specific, short, some good, punchy, technical meat, okay? Some people have made presentations based on what they're doing for their doctoral thesis. You want to teach them you could do a presentation on shooting little drops at liquids, right? That's what his thesis is about. I don't care. I'm not trying to double or triple your work. I'm trying to reduce your work. So if you've already got it canned, that's fine. During the summer, I teach U.S. Navy officers this course. And a lot of them had to do a presentation before they left their last duty station. They were working in maintenance or engineering on some ship or in a shipyard. And a lot of them had to do a presentation. If it wasn't classified, they can just do that presentation, okay? So you can do anything you want, but you will do a better job if it's something you're interested in. So there is a syllabus that you can look at, if I can get this thing turned on again. And it talks about Steve Lyons' intellectual property in the law. I got it turned on, but I don't know how to, okay. It talks about lightweighting, Don Baskin, and then if I go down somewhere further, it probably talks about Brian. Brian, you're there, but I don't know how to scroll this thing yet. Oh, 2 fingers. No, I'm supposed to scroll with 2 fingers, but oh, maybe I don't. Maybe I'm using a thumb and a finger. I don't know. Mechanics of Structural Materials, Leonardo da Vinci. So, anyway, that's that stuff. I do have. I don't like the way. Cursor. Where's my cursor? There's my cursor. So if we go back to the student presentations. Okay, so you can do Japanese swordsmithing was something people did in the past. Different, a particular technology like sand casting. We've had students do investment casting, which is how you make brass rats. Okay. Student paper presentations, any material topic you like. 10 pages or 10 minutes. Don't be too general. Don't be too broad. I will ask, and I got a date in here on the next slide, for you to define which topic you're going to pick. And if I think it's too general or too broad, we'll help you narrow it down. Don't try to cover too much. How many slides can you have in a PowerPoint for 10 minutes? 10. That's the max. I guarantee you. Okay? Anyway, and we do want you to say something about what your analysis and opinions are. Okay? People have done flying buttresses in the cathedrals, you know, in the West, in Europe. Okay? Now grading. There's 6 requirements. No tests, no quizzes, no finals. I said it's flexibility and stress-free environment. I guess we got time. I'll tell you how I decided that tests and quizzes and finals are worthless, okay? First of all, you're MIT students. If you didn't know how to take a test, you wouldn't be here, okay? And the story that got me thinking about this was about 25 or 30 years ago. I usually get in early in the morning. This morning I didn't get in until about 6:30. But I used to get in early, okay? I also go home early at about 2, okay? I don't like traffic. In any case, most of my life I have gotten up, gotten dressed, had breakfast, and out of the house before anyone else wakes up. And so one time I was sitting there having a bowl of cereal or whatever at the kitchen table, and one of my kids in high school, one of my children, had left their math book on the table. And I think the newspaper didn't come that day, so I decided I'd flip through their math book. And there were 2 pages on every topic. 2 pages on integration, 2 pages on differentiation, 2 pages on exponentials, 2 pages on factorials. I had no idea that mathematics came in 2-page lumps. It was quantized, okay? A new theory of quantum, okay? And I thought about, well, all they're doing is training them to take the SATs. That's all they're doing. Did the students actually learn the math and what to do with a factorial? Okay, no. Okay. It's sort of like doing a derivation on the board. It's 19 should all be 20. Pardon me, what? Oh, did I? Okay. I thought I had updated the dates, but anyway, Brian's the TA, so he's the one who's going to know about these things. He's going to send you the emails on Stellar saying, if you don't do this, you're going to be docked a letter grade. That's what he likes to tell them.
For the undergrads, what we've done in previous semesters is rather than there's a Stellar for 3171 and a Stellar for 3371, it all gets lumped into one Stellar site. So it's all, Jerry usually takes care of that with.
Yeah. She set up the Stellar site. If you have a problem getting on, there's always a few students who do for whatever reason. We've had students cross-register from Harvard and stuff. She's the one to talk to about getting on Stellar, okay? So number 1 is either a paper or a presentation. We need to know by the 20th or 21st, whatever it is, which is just a few weeks away, what your topic's going to be. And I need to know this time, since I'm giving you a choice, whether you're going to do a paper or presentation. I don't mind. I'm hoping some of you will do papers so I don't have to listen to 30 presentations. But Brian's going to help. So I like to listen to the presentations, and sometimes I watch them on on the video. What's going on here? Okay. The next one, you'll be evaluated. Your papers are going to be due if you do a paper at the end of March. You edit other people or you attend presentations of 3 or 4 others and you write some critique of their presentation of their paper. And if you're doing a paper, the final paper is due on May 10th. Presentations will be scheduled in April. Reviews will be in April. Completion of the one-page outline of the modules watched is not due until the end of the term because you'll be watching modules the whole term, potentially. But I'm trying to front-load this course. There is a class every day. If you kind of keep up with this course before all your other courses have gotten crazy, you'll be done with this course. You can be done with this course in early April. And that really, for those of you that are undergraduates and taking a full course load, and even if you're graduate students, if some of you are studying for the general exam or whatever, it's kind of nice to be done, okay? Oh, I did put this in here. So I've got student evaluations from the past. So some students thought this was a very good course, and these are the best ones, and you can read them. And I've talked about the latitude meant that they actually worked harder than if they hadn't. The worst, here's a student. Now, I will say, out of the last 4 years, this was the only bad evaluation, okay? The guy hated me. Well, I didn't like him either, even though I don't know who he is after he wrote this, okay? Okay, but anyway. But there have been some other evaluations. An outcomes assessment. This is one of the Navy officers who's graduated in 2004. He sent me an email last September, which is actually what spurred me to put this together. I learned more and was entertained more in your class than all my other grad classes combined. I've had people tell me it was the best class they took or something, but I never heard it was better than the entire MIT education. Anyway, your practical knowledge is what we all took away. I actually called him up on the phone. I said, "Did you really mean that?" And he said, "Or was that just hyperbole?" He says, "Maybe a little hyperbole, but you've educated the next generation of ship designers in the U.S. Navy, and they like it." And here's one, oops, that was outcomes, oops. What's going on here? Oh, maybe I didn't, oh, the other, I didn't put in, it's probably on the hallway. But there's one from a guy who's a welding engineer who teaches courses in Wisconsin. I put all my courses on YouTube, okay? And so I've had about 40,000 hits on my welding metallurgy course. 40,000 people even know what welding metallurgy is? I mean, anyway. So we've already talked about some of that. For business type things, there is one on what's TQM, okay, and I can tell that story. So when I was department head, I was talking to a bunch of undergraduates, and I had actually taken TQM when I was a student at the Sloan School. I took the Senior Executives Program at the Sloan School in 1988, and I was head of what they called Leaders for Manufacturing, which was joint with Sloan, and they were big on total quality management, which is TQM. And I said to the students, "Does anybody know what TQM is?" And one student back says, "It's bullshit." And I said, "Well, you may be right. But why did the CEOs of some of the largest corporations in the country give the university challenge to 6 of the top universities? I think Stanford and MIT, and I don't remember the others, but we had the opportunity to go to IBM at their executive training facility on the Hudson for a week. And 75 MIT faculty, we drove out there, we stayed there for a week. Beautiful facility, wonderful food, okay? And IBM taught us what they called customer-driven quality. Voice of the customer, all these types of quality management things. And I said, why would these CEOs think that TQM is so wonderful if it's all bullshit? So that's what that module is. Is it bullshit or is it real? And the answer is it's actually both, okay? It depends on what parts of it you want to get into. So what I'm going to do, oh, it's time, I got to let you go. For on the next Monday, I think next Monday's a holiday, so I won't be lecturing. And I'm not going to lecture. I am going to try to answer whatever questions you want. I've been here for over 50 years. If you want to talk about Epstein, I'll tell you what I know about Epstein. You may not be happy, okay? If you want to know about the tenure process at MIT, I will tell you the truth, okay? Because they can't touch me. Okay? So you ask me whatever you want, and I'll tell you.
Just clarify, you're not talking about Alexander Epstein.
Right. Well, that's been one of the students' interests. But so that's what I'm going to do rather than lecturing on 3491. Okay? I'm going to come in.
He's definitely one of the top engineers I've ever met, so you can also ask him questions about engineering.
I got stories, okay? Some of the postdocs looked at my last 4 years of lectures and came up with 551 stories that I told. So, yeah.